All right, so today we're going to be doing October-November 2023, paper 2-1. Okay. October-November 2023, paper 2-1, right? Paper 2, variant 1. Now, let's start. Question number 1. Choose from the list of compounds to answer these questions. Okay. Each compound may be used once, more than once, or not at all. Identify the compound that is a toxic gas produced by the incomplete combustion of carbon-containing compounds. So that would be carbon monoxide, right? It's a toxic gas that's produced by incomplete combustion, right? Remember, carbon dioxide is produced in complete combustion, carbon monoxide is produced in incomplete combustion. So carbon monoxide. Turns anhydrous copper 2 sulfate blue. Remember, anhydrous copper 2 sulfate is a test for water, right? Test for moisture, right? It goes from white, anhydrous copper sulfate is white, and hydrated copper sulfate, that's the one with the water of crystallization, is blue, right? So white to blue. You can also use anhydrous cobalt 2 chloride, right? That turns from blue to pink. Okay, so this is water. Okay, it's a test for water, right? Leads to deoxygenation of water in rivers. Okay, so this fertilizers, and fertilizers contain nitrates, right? So over here we have sodium nitrate, right? So the nitrates, specifically nitrates जो होते हैं fertilizers में, right? They lead to the deoxygenation, right? So that would be sodium nitrate. An aqueous solution gives a white precipitate on addition of acidified aqueous barium chloride. Aqueous barium chloride. Okay, so barium chloride. Okay, now barium के साथ sulfate gives a precipitate, white precipitate, and chloride के साथ silver ions give a white precipitate, right? Again, barium ions are a test for sulfate, right? So barium sulfate could be the white precipitate or silver chloride, right? Because barium can form a white PPT with sulfate, because silver can form a white precipitate with chloride. So here the answer would be sodium sulfate, right? We've got sulfate over here. So sulfate, remember, sulfate will give a precipitate with barium, right? You'll get barium sulfate, solid. I'll remind you guys that the tests for the ions and gases and flame tests and all of that stuff is required knowledge for your theory exam, okay? It's given in the practical, but it's not given in the theory exam. It is required knowledge. So the answer is sodium sulfate. Contains an anion with a charge of -1. Okay, I mean anion. So these are all obviously covalent. Sorry, this is oxide is O2 minus. Oxide is oxide ion is 2 minus. So that's not it. So this is covalent. Covalent chloride is 1 minus. So lead chloride is ionic, right? Because lead is a metal and non-metal. The chloride is 1 minus, right? Group 7. Nitrate is also 1 minus, right? Sodium nitrate again is ionic. Nitrate is 1 minus. So either one, lead chloride or sodium nitrate. Potassium is an element in group 1 of the periodic table. Copper is a transition element. State 2 physical properties of potassium that are different from those of copper. You guys remember group 1 elements have low density, right? And they're highly reactive. Oh, well, reactivity would be a chemical property. So we're only looking at physical properties. So low melting point. Remember, group 1 metals have low melting point and low densities, right? Whereas transition elements have high melting points and high densities, right? Another difference is that group 1 metals are very soft, can be cut with a knife, whereas transition elements are very hard, right? That's another difference in physical property. So we can say K has potassium has lower density. Potassium has lower density than copper, right? And it has a lower melting point. Okay. Yeah, yeah, they're both malleable, yes. Potassium has lower density than copper, and potassium has a lower melting point. Than copper. Okay. Complete the diagram in figure 2.1 to show the electronic configuration of a potassium ion. Okay. Now, potassium ions, potassium is in group 1, I'll remind you guys, right? Group 1 elements form 1 plus ion, right? So potassium के कितने electrons होते हैं? 19. It's lost 1 electron, so it has 18 electrons, right? Because it has 1 plus charge. It's lost 1 electron, it has 18 electrons, right? So because it's in group 1, right? So potassium K plus has 19 minus 1, which is 18 electrons, right? That would be 2, 8, 8. Okay, so potassium का charge क्या होता है? 1 plus, right? Charge क्या होता है? 1 plus or just plus, right? You can say just plus as well. That's also fine. Okay, and 288. So 2 electrons, then 8. You can use dot, yeah, across either one is fine. And then 8. 288. All right. Table 2.1 shows the observations when 4 different metals react with cold water. Table 2.1 shows the observations when 4 different metals react with cold water. Put the 4 metals in the order of their reactivity. Put the least reactive metal first. Okay. So, well, we can see that the least reactive is vanadium, right? Because no bubbles are seen. Yes, and the most reactive is potassium because the bubbles form rapidly. Right? So always start at the most and the least. That's the easiest way to start. And then we have slowly with cerium and very slowly with uranium, which means uranium is less reactive, cerium is more reactive, right? Because very slowly means obviously slower than just slowly. So uranium and cerium. Okay. Deduce the number of protons and neutrons in the copper atom shown. This is the proton number, okay, 29. And this is the mass number, which is protons plus neutrons, right? So you just do 65 minus 29, that gives you 36. So that is 36 neutrons. So yeah, this is protons plus neutrons, right? 65. In the presence of oxygen, copper reacts with sulfuric acid to form copper 2 sulfate and water. Construct the symbol equation. Symbol equation means a regular equation, right, with the chemical formula. Presence of oxygen, copper reacts with sulfuric acid to form copper 2 sulfate and water. Copper doesn't normally react with acids, right, because it's unreactive, guys. If you remember the reactivity series, copper is less reactive than hydrogen. Copper, silver, gold, right? They don't react with acid normally, but in the presence of oxygen means you have copper, you have sulfuric acid, and in the presence of oxygen means you also have O2. Okay? In the presence of oxygen means that you also have O2. All right, and then what do you end up getting? You get
copper sulfate and water.
CuSO4. Yes, you get CuSO4, that's copper 2 sulfate, Cu2 plus SO4 2 minus. So CuSO4 and H2O. Okay. And then you have to balance this equation. All right. So we have, let's start with sulfate to वहीं का वहीं है, right? Let's leave the sulfate alone because that's complicated. We have 2 oxygens here, which means we're going to have 2 oxygens here, right? To balance this. to balance this, right? Leave the sulfate as it is because it remains the same throughout, right? It's a spectator ion. So what do we have here? We have two H2O, right, to balance these oxygens, and then we have four hydrogens here, right? Two H2. So then we're gonna have a two H2 over here, and then you have two sulfates over here. So you're gonna have two sulfates over here, right? And then you have two coppers, so you're gonna have two coppers here. So this is the balanced equation. This is the balanced equation. I'll repeat how I balance this again. Okay. So what did I do? Again, I'll repeat. First, I just balanced the oxygens using this, right? Because O2, again, remember sulfate, sara ka sara yahin se aa raha hai, right? This entire thing is coming from here, right? On the right. The sulfate on the right is coming from the sulfate on the left. So we can leave that. We have two oxygens here, we have one here. So we say two H2O. Then we have four hydrogens here, two H2. We're gonna have four hydrogens here. Okay. Then we have two sulfates here. We're gonna have two sulfates here. And then we have two coppers. So we have two coppers on the left. So that's the balanced equation. Copper can be used as a catalyst. State how a catalyst increases the rate of a chemical reaction. Well, a catalyst lowers the activation energy, right? It lowers the activation energy. Just have to state it. Do not have to explain it. Name the catalyst used in the contact process. Very common mistake is that people don't read the keyword. It says name, so you have to give the name, which is vanadium 5 oxide. Okay? V2O5 is the formula. Vanadium 5 oxide. Give two reasons why copper is used in electrical wiring. It's very ductile, right? Ductile means it can be drawn into wires, right?
Good conductor of electricity.
Yes, and it's a very good electrical conductor, yes. So it's a good electrical conductor. Yeah, good conductor of electricity. A student investigates. Don't say malleable over here, guys. Specifically, wiring ki baat karte, the ductile. Ductile means it can be made into wires. Okay. A student investigates the reaction of small pieces of zinc with dilute hydrochloric acid at 25 degrees Celsius. Okay. Small pieces of zinc with dilute hydrochloric acid at 25 degrees Celsius. Complete the equation for this reaction by adding state symbols. Okay. Zinc is a metal, solid metal. Okay. Hydrochloric acid will always be aqueous. Zinc fluoride is aqueous. Hydrogen is a gas. Right? Figure 3.1 shows the volume of hydrogen released as the reaction proceeds. Reduce the time taken from the beginning of the experiment to collect 39 cm cube of hydrogen. We just go on the graph. सही Now, पहले देखो scale देखो 39 cm cube, right? So we have cm cube volume of hydrogen on the y-axis. So we're going to say 10, 20, 30, 40, right? So each little square is 1. So this would be 39, right? So we're going to say, okay, this is 39. So let's mark that, right? Then we're just going to draw a horizontal line, right? And read the time. It says 150 seconds, right? 150 seconds per hour. Okay, so the time taken is 150 seconds. The student repeats the experiment using dilute hydrochloric acid with a higher concentration. All other conditions stay the same. All other conditions stay the same. Draw a line to show how the volume changes when dilute hydrochloric acid of a higher concentration is used. Okay. Okay. Now, the first thing to note over here, is that zinc is the limiting reactant. Why? Because we know that the hydrochloric acid is in excess. That's given in the question. Okay. So if I increase the amount of hydrochloric acid, will it affect the total volume? Will it affect the total volume or not? So because zinc is the limiting reactant, right? Since we're not changing zinc, we will not affect the total volume. So the final volume will still be 42. The final volume will still be 42. Okay. You still get 42 cm cube of hydrogen gas. Okay. However, because you're using a higher concentration, right? If you're using a higher concentration, it means that your rate will increase. Rate will increase, where the total is the same. Total amount is the same, right? Because zinc is unchanged, right? That's your limiting reactant. That's your limiting reactant. So that means you're going to produce the same 42 cm3 but faster. It's going to take lesser time, right? It's going to take lesser time. Just say yahan par it took around like this long, right? 200 and maybe 15 seconds roughly, right? To reach 42 cm3. It's just going to be quicker. So it's going to be the same graph, similar looking graph, but like this, right? And you have to just sketch this with a pencil. Always use a sharpened pencil for these diagrams, guys. Okay, make sure it levels off at the same volume. Levels off at the same volume, like that, right? So it's just produced at a faster rate, right? Produced at a faster rate, so steeper line, okay? The student repeats the experiment at 30 degrees Celsius. All other conditions stay the same. Describe and explain using collision theory how the rate differs when a temperature of 30 degrees Celsius is used. So initially your temperature was 25 degrees Celsius. So you have increased the temperature. If you increase the temperature, the rate of reaction will increase. First, just it says how it differs. So just state the effect, right? So the rate increases. The rate increases. And the reason why is because as the temperature increases, the particles have greater speed and kinetic energy. Now, because they have greater speed and greater kinetic energy, right, it means that hence we know that more particles have energy greater than or equal to the kinetic energy. Now, what does that mean? They go more particles have energy greater than or equal to the activation energy. What that means is that a particle needs this much energy to react. A particle needs the activation energy to react. Now, if you increase the temperature, right, pehle only a few particles had enough energy to react, right? But now because you've increased the temperature, more particles have high energy, right? The more particles have higher energy, right? That means you have more particles that have enough energy to react. You have more particles that have enough energy to react, which means that the rate of reaction increases, right? More particles have enough energy to react. So that means more particles have energy greater than or equal to the activation energy, right? And as a result, what happens? The frequency of successful collisions increases. Successful collisions are collisions that result in a reaction. Successful collisions are collisions that result in a reaction. So frequency of successful collisions increases. A sample of hydrogen is put into a gas syringe. The end of the gas syringe is then blocked so that no gas can escape. Explain why decreasing the pressure increases the volume of the gas when the temperature stays the same. Okay. Now, when you increase the pressure, right? When you increase the pressure, let's say you have a syringe, right? If you guys have ever seen a syringe, right? You have a plunger over here, right? When you apply pressure, what happens to the space between the particles?
decreases. Decrease.
And what if you decrease the pressure? So you allow it to release. Obviously, the space will increase, right? So it's the opposite effect, right? So when you increase the pressure, the space between the particles decreases because gases can be compressed because there's a lot of empty spaces. And when you decrease the pressure, the space increases, right? If you decrease the pressure, the space increases. So we can say that the space between particles increases, right? And they move further apart. The particles move further apart and the space between them increases. Okay, so particles move further apart and the space between the particles increases. Space between particles increases. Concentrated aqueous calcium bromide is electrolyzed using graphite electrodes. Predict the product at each electrode. Okay, you got concentrated aqueous, right? Aqueous, concentrated aqueous calcium bromide. Now, calcium bromide, you have calcium, which is group 2, so calcium ions and Br minus. Right now, you guys need to remember the rules. For cathode, it's always hydrogen, except when it's copper or silver or gold. We don't really even see gold, so it's pretty much always going to be copper or silver. Okay, if you have copper or silver, then you're going to see it at the cathode. Otherwise, it will always be hydrogen. At the cathode, you're going to get hydrogen gas, right? The ion will be H plus. H plus will undergo reduction, right? H plus will gain electrons to form hydrogen gas, right? H plus will gain electrons to form hydrogen gas. So the product of the cathode is hydrogen gas. Okay. An aqueous solution at the anode. Okay. So let me write this down. At the cathode, always H2, except if it's copper, silver, or gold. Okay. This is for aqueous solution, right? Aqueous electrolysis. At the anode पे क्या होता है? If it's dilute, it's always oxygen. If it's dilute, it's always oxygen, and if it's concentrated, it's going to be the halogen. If it's concentrated, it's going to be the halogen. Here we do have a halogen. We have bromide. Bromide is the halide, the anion. So the product will be the halogen, which is bromine. Okay, the product is bromine, right? Bromide will lose electrons to form Br2 and 2e minus, right? Anode पे oxidation होती है, loss of electrons. Molten calcium bromide, molten just means liquid. There's no water, there's no H plus or OH minus. Okay. So in aqueous solution, if it's a dilute solution, it's always going to be oxygen. A dilute solution will always be oxygen. Hydroxide will give you oxygen, right? And in concentrate, it's always going to be the halogen. Okay. Nitrate sulfate, never. Nitrate sulfate never never discharge at the anode. Okay. Now, if it's molten, it's just liquid. So just pure calcium bromide. Just pure calcium bromide. So anode पे क्या होगा आपका anion, right? Which is Br minus. It loses electron. It forms bromine and E minus, right? Now, because we have Br2 over here, okay, it has to be. Remember, molten में क्या होता है? The ionic compound is broken down into the elements. Okay, broken down into the elements, which means आपका क्या बनेगा? Calcium बनेगा और bromine बनेगा, right? Broken down into the elements. That means that bromide will form the element Br2. Element is Br2, not Br. It is Br2. Okay. And since you have two bromines here, that would be 2 Br minus. Now each bromine loses 1 electron, so 2 bromines will lose 2 electrons. And then calcium is 2 plus. It's going to form calcium metal. So it's going to gain 2 electrons. It's going to gain 2 electrons, right? Describe a test for aqueous bromide ions. Bromide,
Silver nitrate.
yes. For bromide ions, the test is silver nitrate. The proper reagent is acidified silver nitrate, right? It's basically it is dilute nitric acid followed by silver nitrate. But
Yeah.
they accept silver nitrate, okay? But I still write that down. So it's dilute nitric acid. I'll write down the full one. Okay, dilute nitric acid followed by aqueous silver nitrate. Okay. This is the full test that we use. The key part over here is saying silver nitrate. Okay, but the full reagent is dilute nitric acid followed by aqueous silver nitrate, and the observation is you're going to see a
Cream precipitate.
cream precipitate with chloride. It's white, bromide is cream, and then iodide is going to be yellow. Calcium reduces zinc ions to zinc. Explain in terms of the movement of electrons how calcium acts as a reducing agent. Reducing agents undergo oxidation. Reducing agents undergo oxidation, right? In other words, they lose electrons. They lose electrons, they give their electrons to something else. तो दूसरी चीज electrons gain करती है, खुद ही lose करते हैं और दूसरी चीज को reduce करते हैं, right? तो खुद ही oxidize दूसरी चीज को reduce करते हैं. They undergo oxidation themselves, reduce the other thing. So here we can see calcium is losing electrons and it's giving those electrons to zinc, which is gaining electrons, right? So we can say that at the full thing over here is going to be calcium loses electrons and itself is oxidized. Whereas don't say zinc ions, okay? Whereas Zn2 plus gains electrons and is reduced by the calcium, right? By calcium metal. Yes, you have to learn all the tests for cations, anions, gases. It will be tested. All of them. You need to know all of them. Flame tests, tests for nitrate, tests for sulfate, tests for everything. It can come in the theory exam. You need to know.
सर
There
पर
are
जो एटीपी
5
का
flavors.
होता है उसमें तो वो दिए हुए होते हैं ना
किसमें दिए हुए होते हैं?
एटीपी में
एटीपी में दिए हुए होते हैं और थियरी के एग्जाम में आएंगे तो क्या करोगे?
तो मतलब पूरे मेमोराइज करके जाने पड़ेंगे
जाना पड़ेगा. 80% आपका ग्रेड है ही थियरी.
ओके ओके
यस, यू हैव टू लर्न इट. कोई इसमें गुंजाइश नहीं. कुछ भी आ सकता है. इसी पेपर में आ गया. आई थिंक फ्लेम टेस्ट आता है. फ्लेम टेस्ट भी आ सकता है. टेस्ट भी आ सकते हैं. बोलो.
How many flame tests are there? 5, right?
6.
Okay.
Lithium, sodium, potassium, calcium, barium, and copper. State the oxidation number. Oxidation number is just the charge, so it's going to be +2, right, on the ion. All right. Sulfur dibromide is produced when sulfur reacts with bromine. Complete figure 4.1 to show the dot and cross diagram for a molecule of sulfur dibromide. Show the outer shell electrons only. Okay. So if we draw a dot and cross diagram and show outer shell electrons only. Now first, I'll remind you guys, sulfur is in group 6 and bromine is in group 7, which means sulfur has 6 valence electrons and bromine has 7 valence electrons, which means bromine only wants one more. Bromine only wants one more. It wants to make a single bond. That's it. Sulfur wants 2 more. So it can make a double bond or 2 single bonds. You can make a double bond or 2 single bonds, right? So then if you go back up, right? Let me write that down. Sulfur has 6 valence electrons and bromine has 7. Bromine only wants to make single bonds. So sulfur को 2 bonds चाहिए, which means that it will make 2 single bonds with the bromine, right? It will make 2 single bonds with the bromine, right? Right? Because हमें कितने valence electrons चाहिए? 8, right? So we have a single bond. Okay. Now sulfur के 6 valence electrons हैं. Okay, let's say dot represents sulfur. 2 of them are shown. Which means you have 4 more. Okay, means you have 4 more. Bromine के 7 valence electrons हैं. Only one of them is shown for this bromine, which means you have 6 more. Right? And then same thing here. 1, 2, 3, 4, 5, 6. Figure 5.1 shows the displayed formula of compound A. Draw a circle around the functional group that is also present in alkenes. Alkenes have a carbon-carbon double bond. Draw a circle around that. Okay, that's the functional group present in alkenes. Deduce the molecular formula. Molecular formula में सारे एक जैसे atom एक साथ. All atoms of the same type of the same element have to be written together. We have 1, 2, 3, 4, 5, 6 carbons. We have 6 carbons, so C6. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, so H10. And then we have 1, 2 oxygens, so O2. Okay. Compound A is a solid at 20 degrees Celsius. Describe the motion and arrangement of the particles in a solid. So, solid में किस तरह का motion होता है?
Vibrate at fixed positions.
Yes, the motion is vibration, exactly, right? Vibrate. The particles vibrate in fixed positions, right? They're not free to move around in a solid. The particles vibrate, right, in fixed positions. And the arrangement is that they have a regular arrangement, right? Closely packed. But closely packed has got to do with the distance. The arrangement is that you have a regular arrangement, right?
Can we write like tightly packed?
Yeah, but you have to mention the arrangement,
Oh,
right? Because they could be tightly packed but not be regularly arranged. Like, are these regularly arranged? No, right? But they are tightly packed. इसमें क्या है? They're regularly arranged and tightly packed, right? Does that make sense? The difference? Yeah. So, okay, so let me write that. Let me write down the full statement. Particles are held close together in a regular arrangement, or tightly packed in a regular arrangement. Okay, regular arrangement. You have to mention the arrangement. In liquids and gases, it's not regular, right? It's a random arrangement. Not all solids have a regular arrangement, but for as far as we're concerned, okay, all solids have a regular arrangement as far as O-level papers are concerned. Okay. Alkenes react with hydrogen in the presence of a catalyst. Draw a circle around the type of reaction. Alkenes undergo addition, right? And the catalyst we use is nickel. If you guys remember, nickel catalyst हम लोग alkenes की reduction के लिए use करते हैं, right? We react it with hydrogen. It's called hydrogenation. We use a nickel catalyst और आपकी addition हो जाती है, right? What happens? Double bond breaks and you add the two hydrogens, right? Alkene is converted to an alkene. Okay, again, if it says name the catalyst, okay, don't say Ni, please. Make sure you name. Figure 5.2 shows the structure of compound B. Compound B can be polymerized. Draw two repeat units of the polymer formed when compound B is polymerized. Okay. Now for this is what type of polymerization?
condensation.
Alkene. Alkenes undergo addition polymerization. Yes. Condensation is जब आपके polyester या polyamide बनता है. Right? यहाँ पर वो कुछ भी नहीं है. Right? Alkene. Right? So we have an alkene over here. It will undergo addition polymerization. What happens in addition polymerization? In addition polymerization, right? Your double bond, your alkenes add on to each other. Now, how do we draw it? Again, I'll remind you guys. First, what you got to do is you got to draw the double bond. Just draw the double bond. And all other groups should be arranged above and below. Okay? So draw the double bond, draw the double bond. Everything else will come in branches. Okay? So what do we have? On this carbon, we have a hydrogen and this CH3, the entire thing. In the first carbon, we have a hydrogen and a CH3. Doesn't matter if you draw it above or below. Doesn't matter if it's upper niche. Okay. And is carbon pe kya hai? We have a chlorine and a hydrogen. So again, draw the double bond, and then look at the double bond wale carbon. Look at the first carbon, it has a hydrogen and a CH3. Look at the other carbon, it has a hydrogen and a chlorine. Has a chlorine and a hydrogen. Okay, like that. Yeah. And then how do we draw the repeat unit? We're just going to break the double bond and add the continuation bonds. That's one repeat unit, right? We're going to break the double bond, and add continuation bonds. That is one repeat unit. We're going to need a second repeat unit, right? For the second repeat unit, we're just going to draw the same thing again. Right? So that is two repeat units. This is one repeat unit, this is another repeat, right? Okay. Figure 5.3 shows part of the structure of a protein. Name the type of monomer used to make proteins. What's the monomer we use to make proteins? Building blocks of proteins. Building blocks of proteins क्या होते हैं? Proteins are made from, to the nomadic bio over here.
Amino.
Yes. Monomer is the compound that we use to build it. Protein is a polymer. A protein is a polymer made from amino acids, which are the monomers, right? Amino acids are the starting molecules. Okay, so the type of monomer is amino acids, right? Or amino acid. And the type of linkage is amide, right? Proteins are basically polyamides. Remember, amides mein kya hota hai? C double bond O bonded to a nitrogen. This is amide. Okay, and ester kya hota hai? COOC. This is ester linkage. This is ester linkage, and this is amide linkage. CON. Here we have a CONH, right? So this is amide. अमीनो एसिड्स के केस में हम लोग सिर्फ अमीनो एसिड्स के केस में हम लोग इसको पेप्टाइड भी बोलते हैं. Okay, only in the case of amino acids it is also referred to as a peptide, but the proper name in chemistry is amide. Okay, for the linkage. And again, the type of polymerization here is condensation. Okay, when you make a protein, it's made through condensation polymerization. In the previous example, it was addition polymerization. Okay. The equation for the Haber process used in the production of ammonia is shown. The nitrogen for this process comes from the air. State the percentage by volume of nitrogen in clean, dry air. The percentage of nitrogen is roughly 78%. Okay, 21% is oxygen, and then the remaining 1% is other stuff. Okay, for the Haber process. The forward reaction in the Haber process is exothermic. Okay, what does exothermic mean? Energy released or energy taken in?
Is the energy.
It means there's a release of energy, net release of energy. Right now, if you guys remember, bond making is exothermic and bond breaking is endothermic. So which of the bonds will be greater? The ones that are made or the ones that are broken? If the overall change is exo.
Broken.
Right? Overall change exo है. तो exo वाला ज़्यादा बड़ा होगा endo वाला. Energy is taken in when bonds are broken, and energy is released when bonds are made. What is the net result? Are you releasing more energy or taking it in if the overall change is exothermic? If the overall change is exothermic, there is a net release of energy. Bond making releases energy. So then which energy would be greater? The bonds made, right? समझ आ रही कि नहीं आ रही? मैं मतलब समझ नहीं आ रही मैं क्या बोल रहा हूँ. आपको ओवरऑल अगर एनर्जी रिलीज हो रही है तो ओवरऑल चेंज कौन सा ज्यादा होगा, जो एनर्जी आपने अंदर डाली है, जो आपने एनर्जी रिलीज की एंड में?
जी
अगर
जी
ओवरऑल रिलीज कर रहा है, हाँ समझ रही हो, ओवरऑल रिलीज कर रहा है ना, राइट? सो और यू कैन, okay, if you're not sure about this, you can also look at the equation, right? Delta H is bonds broken minus bonds formed, okay, minus bonds made. Okay, now if the overall change is exothermic means that the enthalpy change is negative. Enthalpy change is negative. So then which is bigger, bonds broken or bonds made, if the overall change is negative? If bonds broken was, let's say, 80 and bonds made was 100, then what's happening? Energy is being, then the overall change is negative, right? So that means that, and we know that the overall change must be negative. That means bonds made ki energy must be greater. Bonds made ki energy must be greater. Products ke bonds, right? Products ke bonds ki total energy must be greater. Okay? Because again, it's reactants minus products, right? Bond energy of reactants minus bond energy of products, right? Products के bonds बन रहे हैं, आप पहले reactants के bonds तोड़ रहे हो, you're breaking the bonds in the reactants and you're making the bonds in the products, right? All right. If the overall change is exo, that means overall change is negative. That means bonds made is greater, right? So then we can say that if the overall change is exothermic, that means this is greater. Bond making is greater. So we can say that the energy released when bonds are made. Okay, energy is always released when bonds are made. Energy released when bonds are made is greater than the energy needed. Okay, energy needed to break the bonds. Okay, so energy released when bonds are made, okay, in the products is greater than the energy needed to break the bonds in the reactants. So the overall change is exothermic. If it was endothermic, it would be the exact opposite. Okay, if it was endothermic, it would be the exact opposite, right? That energy needed to break the bonds would be greater than the energy released when the bonds are made. Okay, the energy needed to break the bonds would be greater than the energy released when bonds are made. Right? उसमें क्या होगा? आपका bonds broken would be greater, bonds made would be smaller. So the overall change would be endo. Does everyone get this now? I hope everyone gets this.
yes
Okay. The transfer of thermal energy in a chemical reaction is called the enthalpy change. Write a symbol for the enthalpy change, including the sign for an exothermic enthalpy change. Okay. So enthalpy change ka symbol is delta H, and the sign for an exothermic enthalpy change is negative. Okay, for an exothermic reaction, the enthalpy change is negative. All right. Aqueous ammonia is an alkali. Ammonia reacts with nitric acid to form a salt. Name this salt. Okay. Ammonia is NH3, reacts with nitric acid to form a salt. Now, if you guys remember, NH3 kya karta hai? It gains a proton. Right? It's a base. It's an alkali. It gains a proton to form NH4 plus. And then आपका रह क्या जाएगा? So NH3 will gain this proton. ये दोनों combine करके क्या बना देंगे? NH4 plus. और ये क्या है आपका nitrate, NO3 minus. So the salt over here would be ammonium nitrate. The salt here would be ammonium nitrate, NH4NO3. Okay. Name the experimental technique used to make a solution from nitric acid and aqueous ammonia. If you're making a soluble salt, remember all nitrates are soluble. All nitrates are soluble, so it's a soluble salt, right? From two solutions, we always use titration. Okay, titration is the, remember when we did salt preparation, right? Preparation of salts. If you want to make a soluble salt, we know it's soluble because we should know all nitrates are soluble and all ammonium salts are soluble, so it has to be soluble, right? And we know that we have a solution of nitric acid, dilute nitric acid, and aqueous ammonia. Aqueous means solution, so we have two solutions. If you're making a soluble salt from two solutions, it has to be titration. All right. Lesson 7. Dilute ethanoic acid, that's this guy, reacts with aqueous calcium hydroxide. Okay, you get calcium ethanoate, that is the salt and water, right? This is neutralization. Acid plus alkali gives you salt and water. Okay, a student reacts 25 cm cube of 0.1 mole per dm cube calcium hydroxide with dilute ethanoic acid using thymophthalene as an indicator. Okay, so we have the concentration and volume of calcium hydroxide. A volume of 12.5 cm cube of dilute ethanoic acid reacts exactly with the 0.01 mole per dm cube aqueous calcium hydroxide. Calculate the concentration moles per dm cube of the dilute ethanoic acid. Okay, so just a standard mole calculation questions. First, convert the known quantity to moles. Right? आपका unknown क्या है यहाँ पर? Unknown is ethanoic acid. Known is calcium hydroxide. We know the concentration and volume. So convert that to moles, right? Calcium hydroxide, the moles is concentration times volume. The concentration is 0.0100, right? Or 0.01 times the volume has to be in dm cube. The volume has to be in decimeter cube. This is in centimeter cube. So we do times 25 over 1,000. Okay. So we get 2.5 into 10 to the power of minus 4 moles of calcium hydroxide. That's the first step. Second step, use ratios to find the moles of the unknown quantity. We have a ratio of 2:1 here. So 1 mole of calcium hydroxide reacts with 2 moles of ethanoic acid. You want to say acid, right? And calcium hydroxide have a 1:2 ratio, 2:1 ratio. We have the moles of this 2.50 into 10 to the power minus 4. We can find the moles of acid, just cross multiply, right? So N is equal to 5.00, double the moles of acid, right? 10 to the power minus 4 moles of acid, right? That's the second step, using ratios. And then the third step, convert to desired units. Third step is going to be concentration is number of moles divided by volume. The number of moles over here is 5 into 10 to the power minus 4. 5 into 10 to the power minus 4. Divide by volume. The volume is in centimeter cube again. We have to convert it to decimeter cube. So volume would be 12.5 over 1,000, right, for the acid, which is 0.0125. 0.0125. And this gives us the concentration as 0.0400. Okay, I'm giving it to 3 significant figures, just like in the question. Okay, everything is given to 3 significant figures, so I'm just giving it like that. 0.0400 moles per decimeter cube. Okay, that's the answer. With moles anymore because I feel like the questions we did ask were a lot more challenging. No, maybe. What do you guys think? हम लोगों ने क्लास में शायद ज़्यादा ही मुश्किल सवाल किया था इससे काफ़ी. Okay. State the color of thymophthalene. You should just remember that thymophthalene is blue in alkali and it is colorless in acid. Okay. Blue in alkali, colorless in acid. Okay, so calcium hydroxide is an alkali, right? Hydroxide, alkali. So it's going to be blue. Ethanoic acid is a weak acid. Define the term weak in the phrase weak acid. Weak means that it partially ionizes, right? Or dissociates partially. Okay? Partially ionizes or partially dissociates. Okay? So it is incompletely dissociates, uh, partially dissociates in solution. Okay? Or incomplete. Incomplete is the better word. Incompletely या partially dissociates. Dissociates भी कह सकता, ionizes भी कह सकते. Incompletely dissociates in solution. Write the formula of an ion, of the ion present in aqueous solutions of acids. That would be H plus. Okay. Ion present in acids. Dilute ethanoic acid reacts with sodium carbonate. Calculate the volume measured at RTP in centimeter cube when 3.18 grams, so volume measured at RTP in cm cube, when 3.18 grams of sodium carbonate reacts with excess dilute ethanoic acid. Okay. So again, same thing, guys. Mole calculation, convert the known quantity to moles. The known quantity here is the mass of sodium carbonate. That's the given, right? You want to find volume of carbon dioxide, the mass of sodium carbonate is given, right? So we can say first, we can start with sodium carbonate. We can say the number of moles is mass over mr, yeah, molar mass, right? Which is equal to, the mass is 3.18. The mr, sodium carbonate is Na2CO3, sodium is 23 times 2, right? Because you have two sodiums, carbon is 12, and oxygen is 3 times 16. Okay, I'll write it down on the side. Na2CO3 का जो molar mass होता है, it is 23 times 2 plus 12 plus 16 times 3, which is 106. Okay, so 3.18 divided by 106, and that gives you 0.03 moles. 0.03 moles. The ratio is 1 to 1. Carbon dioxide again. So first we find the moles of the known quantity. Then we use ratios to find the moles of the unknown. Moles of unknown, moles of carbon dioxide. So again, let me write this down. Na2CO3 to CO2 is a 1 to 1 ratio. So if this is 0.03, then what is this? So we can say N of CO2 is 0.03 moles. And then that means that the volume of carbon dioxide, that's the desired units. Once we have the moles, we can convert the volume of a gas at RTP in centimeter cube. Is number of moles times 24,000, right? If you do times 24, you get dm cube. Multiply that by 1,000, you get cm cube. This is going to be 0.03 times 24,000, and that gives you 720 cm cube. Sulfur dioxide contributes to acid rain. State one source of sulfur dioxide. Sulfur dioxide comes from fossil fuels, burning fossil fuels, right? Because they contain sulfur impurities, right? Mainly, the biggest example is coal. Okay, this that has the generally has the highest amount of sulfur amongst all the fossil fuels. describe one method of reducing the amount of sulfur dioxide, okay, you can use flue gas desulfurization. Okay. Now, what is that? If you guys remember, I'll just explain this. Flue gas desulfurization. If you guys remember, flue gas desulfurization में क्या होता था? Basically, imagine that you have like a chimney, right? Like a factory. Factory is producing smoke. Okay, the smoke contains sulfur dioxide because it's burning fuel, and the fuel has sulfur that can be converted to sulfur dioxide. Now, what you can do is you can use calcium hydroxide at the opening of the chimney before the smoke exits the chimney. Okay, the calcium hydroxide reacts with sulfur dioxide. Okay, calcium hydroxide reacts with sulfur dioxide to form calcium sulfite and H2O. Okay, so what you've done is आपके sulfur dioxide reacts with the calcium hydroxide and doesn't reach the atmosphere. Does not reach the atmosphere. Atmosphere में सिर्फ क्या जाता है? Steam जाता है, right? So you're basically removing the sulfur dioxide. Flue gases are just waste gases from industries. Okay. Another option is you can use low sulfur fuels. You can use low sulfur fuels, but flue gas desulfurization you guys should remember anyways. Okay. In the contact process, sulfur dioxide reacts with oxygen, right, to form sulfur trioxide. Okay. This is something you should just remember. SO3, and it's going to be 2. Okay, and again, the catalyst for this is vanadium 5 oxide, B2O5. Ethanoic acid is manufactured from methanol. The forward reaction is exothermic. Again, delta H is negative. Forward reaction is left to right, is exothermic. Delta H is negative. Predict and explain the effect, if any, on the position of equilibrium. The position of equilibrium when the pressure is decreased. Pressure is decreased and the temperature remains constant. Okay, so you're just decreasing the pressure. Okay, what side does an increase in pressure favor? All right. So you guys should remember that an increase in pressure favors the side with fewer moles of gas. Now on the left-hand side here, we have 2 moles of gas, right? 1 and 1. And on the right-hand side, we have 1 mole of gas. Right? So if you decrease the pressure, the equilibrium will shift to the left. Okay? And why will it shift to the left? If you guys remember the equilibrium में क्या होता है? The equilibrium moves in a direction to oppose the change. अगर आपने decrease किया, if you decrease the pressure, the equilibrium will bring it back up. If you decrease it, the equilibrium will bring it back up. So it will shift to the side with more moles of gas. आपकी gas बढ़ जाएगी, and your pressure will go back up. Your pressure will go back up, right? So we can say here that a decrease in pressure will favor the side with more moles of gas. Okay, increase favors side with fewer, decrease favors the side with more moles of gas. Hence, equilibrium position will shift to the left, right? Hence, equilibrium will shift, position will shift to the left to oppose the increase in pressure, right? You're always opposing the change. You decrease the pressure, you're opposing the decrease by increasing the gas. If you increase the gas, the pressure goes back up. Okay, so oppose the decrease in pressure. Okay. Predict and explain the effect, if any, on the position when the temperature is decreased. Now, when the temperature is decreased, it favors the exothermic direction. Exothermic here is forward. Exothermic is forward here, right? Because remember, why? Because again, we want to oppose the decrease in temperature. अगर आपने temperature कम किया, if you decrease the temperature, you want to bring the temperature back up. How do we bring the temperature back up? Well, by releasing energy. Exothermic reactions release energy, right? So forward reaction will release energy, bring the temperature back up. Forward reaction will release energy, bring the temperature back up. So equilibrium will favor the lower temperature favors exothermic. Okay. So in this case, we will say equilibrium position will shift to the left, right? Equilibrium position will shift to the right. Sorry. Equilibrium position will shift to the right, right? Since the forward, right, shift to the right because the forward reaction is exothermic, right? Since the forward reaction is exothermic, right? Or I should, let me phrase it a little bit differently, right? So, one second. Yeah. Since the forward reaction is exothermic, right? Um, this opposes the decrease in temperature, right? Ethanoic acid can be produced by bacterial oxidation. Describe one other method by using an alcohol other than methanol. So we use ethanol, right? And we can oxidize ethanol using acidified potassium manganate 7. The name of the oxidizing agent is just potassium manganate 7, but the full reagent is aqueous acidified. I'll write this in brackets, right? You should know the name though, potassium manganate 7. Okay, this is KMNO4. Okay, KMNO4. Ethanoic acid reacts with propan-1-ol to produce an ester. Name the ester and draw its displayed formula. Okay. Ethanoic acid is a 2-carbon acid. Ethanoic means 2 carbons, right? So we have CH3, COOH, and we have propan-1-ol, which is CH3, CH2, CH2OH. Now again, to draw the ester, remember, we're going to draw the displayed formula. So we have CH3, C double bond O, right? The acid will lose the OH. The acid will lose the OH and the alcohol will lose the H. And what happens? Acid ka C double bond O, the carbon, this carbon, C double bond O carbon will bond to this oxygen. This carbon will bond to this oxygen from the alcohol, right? The carbon will bond to the oxygen from the alcohol, right? So let me underline this as well, right? This carbon will bond to this oxygen, right? And kya hoga? Again, OH will be lost here, H will be lost here, right? And this carbon will bond to this oxygen. And then what do you get? You have this oxygen is then bonded to CH2, CH2, CH3, CH2, CH2, CH3. And just draw the hydrogens. That's the displayed formula, right? Every bond is shown. And the name of this ester, we always write the name of the alcohol first. So it's going to be propyl, right? At name of alcohol, prop, 3-carbon alcohol, and then YL. So propyl and then ethanoate. Propyl ethanol. Table 9.1 shows the melting points and relative electrical conductivities of three elements. Use ideas about structure and bonding to explain the difference in melting points of magnesium and phosphorus. Now remember, magnesium has a giant metallic lattice. So you have strong metallic bonds that have to be broken in order to melt it, the higher melting point. Phosphorus has a low melting point because it's simple molecular. Simple molecular, do you need to break the covalent bonds to melt it? Do you need to break the covalent bonds to melt it or no? Anyone remember? It's simple molecular. If you guys remember oxygen, for example, let's say take the example of water. Let's take the example of water, right? Water may we have water molecules, right? Now, if you want to boil water, you get steam. Steam is still H2O. Have you broken the covalent bonds? Have you broken the covalent bonds in water when you vaporize it? Does it remain
No.
H2O? You haven't, right? H2O remains H2O. The bonds between the hydrogen and oxygen remain intact. What have you broken? You've broken the intermolecular forces, which are much weaker, right? That's what we mean by simple molecular. सिंपल में आपको इंटरमोलेक्युलर फोर्सेस तोड़नी होती हैं. जायंट में क्या करना होता है? आपको बॉन्ड्स तोड़ना होता है. So in giant structures you have to break bonds, and simple molecular you only have to break intermolecular forces. So magnesium is giant metallic, you have to break metallic bonds. Similarly, carbon is macromolecular, you have to break covalent bonds. Okay, because it's giant covalent, right? Ionic are giant ionic, so you have to break ionic bonds. And you have three giants, right? You have three giant structures. You have giant में you have ionic, you have covalent or giant covalent, which is macromolecular, and you have metallic. In all of these, you have to break bonds, so they have high melting points. Whereas in simple, you don't have to break bonds, you only have to break intermolecular forces. The only exception that has low melting points in giant that we learn about is group 1 metals. Those are relatively low melting points, right? That's the only one we learn about. Otherwise, all the giant structures are very high melting points. Okay. So, why is there such a difference? Because magnesium has a giant metallic lattice, right? Giant metallic lattice structure, right? Hence, strong electrostatic forces, electrostatic forces of attraction between metallic lattice में क्या होता है? Between cations and delocalized electrons have to be broken. Okay. And these attractions are stronger, right? This requires more energy. Okay, this requires more energy than the weak intermolecular forces between phosphorus molecules. Okay. The difference in electrical conductivities of graphite and phosphorus. Graphite has delocalized electrons, right? Which are free to move in the giant lattice structure, right? So graphite has delocalized electrons right, that are free to move. Along the layer of graphite, right? Along the layer of graphite. Whereas phosphorus does not, right? Phosphorus has no free ions or electrons. Okay? दोनों चीजें, right? Because ions भी carry कर सकते हैं, जैसे like you have in liquid ionic compounds या aqueous ionic compounds. You have to have free ions or electrons, right? Diamond and graphite are different forms of carbon. Describe in terms of structure and bonding why diamond is used in cutting tools. Okay. So diamond has a macromolecular, a giant covalent structure. Okay. Has a giant covalent structure. Okay. With strong covalent bonds. With strong covalent bonds between all the atoms, right? There's no intermolecular forces, just covalent bonds, right? Just all the carbons are connected to covalent bonds, making it very hard and suitable for cutting tools, right? Okay. A compound of phosphorus, oxygen, and chlorine contains 20.2% phosphorus, 10.4% oxygen, and 69.4% chlorine by mass. Deduce the empirical formula of this compound. So we have phosphorus, oxygen, and chlorine, right? For empirical formula, we just use atoms. For empirical formula, we use atoms, okay? And then we have the masses given to us, right? So we're going to take the percentages as grams. Just take the percentages as grams. So what do we have? We have 20.2, we have 10.4, and we have 69.4. We need to find the mole ratio. We need to find the mole ratio. So we're going to divide by the atomic mass, right? We're going to divide by the atomic mass or the molar mass. So phosphorus ka molar mass from the periodic table, right, is 31. This is the mass, huh? This is the atomic number. So mass 31, oxygen is 16, and chlorine is 35.5. So we're going to divide the first number by 31. I'm going to divide this by 16. I'm going to divide this by 35.5. Okay. And then we get 0.65, 0.65, and 1.95. Then you just divide by the smallest number, 0.65. You get 113. That's the ratio. So the empirical formula is POCl3, right? 1 phosphorus, 1 oxygen, and then 3 chlorine.